Let's consider solubility of compounds. As an example, the sodium chloride molecule will dissolve in water to give sodium plus and chlorine minus atomic ions. However, the silver chloride molecule only very partially dissolves in water. So basically, we say that the reaction doesn't occur because it occurs to such a small extent. So sodium chloride, table salt, is soluble. Sodium or silver chloride is said to be insoluble in water. Now, books have tables of solubility rules, and I've put one on Blackboard for you to use, and it is a table of the possible pairing of cations, positive ions, and anions, negative ions, and whether they are insoluble or not. So you have the cations, which are the positive ions, and the anions, which are the negative ions, and these can pair just like in sodium chloride, and some are soluble, some are insoluble, depending on the possible pairings in water. Now, if you look at the periodic table, Group 1A, starting with lithium and going through francium, these atoms like to give up an electron, so they will have the same number of electrons as the noble gas, Group 8A. Group 2A, beryllium through radium, want to give up 2 electrons so that they can have the same number of electrons as the noble gas, Group 8A. So that way we can predict the charge on these ions. And then Group 7A, fluorine through astatine. These atoms want to gain an electron. So that they will have the same number of electrons as Group 8A. So this way we can predict the charges on the molecules. So if we have sodium fluoride, we would predict that sodium would have a positive charge, fluorine would have a negative charge. If we looked at magnesium chloride, magnesium wants to have a +2 charge, and chlorine wants to have a minus charge, so we would need 2 chlorine minuses to pair with the magnesium 2+, so that the total charge would be 0. We'll learn more about this when we do electron configurations later chapter this semester. This is an easy way of being able to predict charge. There's also a table of molecular ions in books, and I posted one on Blackboard for you that gives a molecular ion and a name. You don't need to memorize these, but it's there for your use. So say we have the NO3 minus ion. This is called the nitrate ion. So it is a molecule with a charge on it. Another common one is the sulfate ion, and it has a -2 charge. So if I was going to form a compound between sodium and sulfate, since sulfate has 2- charge, sodium only has +1, so I would need 2 sodiums giving a total of +2 charge, and 1 sulfate with this -2 charge to give a compound. This is called sodium sulfate. When placed in water, this will dissolve to give 2 sodium plus ions and the sulfate 2- ion. So now, let's say we have barium sulfate. Barium is from group 2A, so it wants to have a 2+ charge. The sulfate minus has a 2- charge, and so we only need 1 barium to balance the 2- charge coming from the sulfate group. So, will it dissolve in water? Well, we look in the solubility rules table, and we see that sulfate is soluble except when paired with barium 2+, lead 2+, silver, or calcium 2+, or strontium 2+. So this would be insoluble in water. It's easy to predict which ions our compounds are soluble and which are insoluble just by simply looking at the table and pairing the positive ion to the negative ion and looking at the table to see if it's soluble or not.